So here we want to figure out the sine, cos, and tan ratios. So to do that, we need the third side. Okay, the third side along here using Pythagoras, we're going to use 20 squared minus 9 squared. So 20 squared is 400, minus 9 squared is 81. So we end up with 319 square root. Okay, and remember that now we slightly changed our definitions. It's important to distinguish that this is positive because to define this angle here, we need to go to the right. Okay, now that differentiates the same triangle in the different quadrants. So there's my adjacent or my x coordinate. So the cosine ratio is going to be square root 309 over the hypotenuse or the radius. Okay, and we're going to leave it as that. We're not going to write the decimal value for that. So this is going to be sine. So sine is vertical. So we're going to use 9 over the hypotenuse or the radius, which is 20. Okay, we've worked out the x coordinate here. I should write that down. The x coordinate was 319, and I'm going to emphasize the fact that it's positive, okay, because it goes to the right. The tan is my slope, so 9. And again, notice I'm dealing with the ratio, not the angle. Okay, so 9 over 319. So all this is done without having to use any decimals because I've been given a ratio description. I'm just sticking with the ratio description. Now I want to switch to the angle description of that shape. To do that, I need to undo one of these ratios. So I'm going to use cosine in this case. So I'm going to use, since cosine theta equals that, I can say that theta is equal to the undoing or the inverse of that cosine ratio. So now I'm going to input the angle. I'm going to use that as part of the calculation, and that undoing of that calculation is going to give me the angle. The angle I'm getting here is, when I put it into my calculator now, okay, so I need to do 319 square root, okay, divided by 20, and then I want to undo the cosine, so arc cos, I get 26.74 degrees. Okay, so 26.74 degrees. Again, this shape is about right, and that angle looks about right. That's the angle description of the shape that was given to me with the ratio values. Okay, so this one here, we have been given the ratio and a side. Okay, so I want to work out the different pieces here. Now, because I've only been given the side value here, it's going to be a little bit hard to work out the exact value. So now the decimal here implies that we kind of need to use our calculator. So I'm going to first start off with converting this to theta. Okay, so I'm going to go the inverse cosine of 0.250 is going to give me, so 0.250, it gives me 75.52 degrees. Okay, so I can then work out my sine values by plugging in. Since I'm already dealing with decimals, it'd be okay to plug in, but really let's solve this slightly differently. So let's first figure out our y and r, and then we can figure out our sine as a ratio of two numbers. Okay, so I'm going to do this. So I'm going to calculate my y value this way. So y, I know that if I use, let's see here, well, let's start with r. We're going to start with the radius, because with the radius, we can use these two sides and say that 10 divided by r is equal to the cosine ratio, which is equal to 0.250. And if we solve for r, okay, so I have my equation 10 is equal to 10 divided by 0.250 is equal to r when I cross multiply that. So I get an r value that's equal to 40. Okay, so my r is 40, and I'm going to use that to calculate my y value. So y squared is equal to 40 squared minus 10 squared. So I get y is equal to 40 squared is 1600 minus 100 is going to give me 1500. So the square root of 1500. So y is square root 1500. Okay, and then I can work out my sine ratio by plugging in square root 1500 over the radius, which was 40. And the tan ratio is going to be the y value, square root 1500 over the x value, which is 10. Okay, and we can simplify that ratio if you want, or you can just leave it in that way.